I've been working on this automatic keyer for a couple of days now. I won't bore you with all the details, but I was able to, of course, replace all of the capacitors, particularly the ones in the power supply, or the ones that relate to the power to the tubes. And this is also a lesson on paying attention to instructions, because I found a schematic in the manual that I printed out from the War Department, and I had discovered a schematic in this 300-page document, and it illustrated the unit, as you can see here, a conceptual drawing of the unit, and it suggested 3 different types of tubes. There's the lamp, the exciter lamp, and then an amplifier, audio amplifier, oscillator, and power. There's the hand crank that we see on my unit. There's the aperture bar and the guides, and all of that corresponds to what we see here. There's the exciter lamp, aperture bar, a hole goes through into a photocell below, then the four tubes, and the hand crank, and so on and so forth. And so I've used the schematic that they suggested with the tube complement that they recommended in this document, but I completely ignored the instructions on the side of the unit that we had read a moment ago for 117N7 GT tubes. I don't know, I got sidetracked. I got a little excited about finding a schematic, and these are 4. There are 4 of the same tubes. So I went out and I bought one of the tubes that was suggested in the schematic, and I was going to put it in here, and I was going to try. And then it occurred to me one night, in the middle of the night, that this said that it uses 4 of the same tubes. So, bottom line is, I replaced the caps, replaced the exciter lamp. You see here, 15-watt exciter lamp, got off eBay, or off of Amazon, and fired it up, plugging in my old-timey speaker. This is what they call the monitoring speaker, and so this is what we ended up with. So, for all of you code fanatics out there, you could tell me what those letters were. I'm going to run the audio through a little processor on the phone and identify the letters or the words. I'm not sure what if they're just producing random words or random letters or what, but we'll find out in a minute. And then the rewind is okay. This is the adjusts the sensitivity of the photoelectric cell, which is down under here. We saw it earlier. So there we have it, a working unit. Now there's one other piece of information that I just have to show you, and I'm going to show you the a close-up of the unit. Now remember, this unit comes with another tape puller. Right there it's listed, a tape puller. So the tape runs this direction, and then you use this handle to rewind it. So we discovered that's all working correctly, just needed a couple of drops of oil, and it rewinds just fine. But another thing that I discovered just a moment ago is this little piece of information here. Notice that the actual model number is G813-742 graphic keying unit, and this is the keying section of the 813. So I'm on the search now for another 813-742 that includes the tape puller, the associated tape puller. Now I can build one of these with a 3D printer and some electronics and a little servo motor, switch, and a speed control. I can do that, but wouldn't it be great if I could find a complete 813-742 automatic keying unit? So that's where things stand today on the McElroy automatic keying unit. Thank you for watching. Oh, a postscript. These terminals that we identified earlier are speaker terminals, but if we read the instructions, it states that those terminals also produce a 1 to 3 volt, I think is what it says, 1 to 3 volt flashing lamp for burning blinker reading training. And sure enough, I hooked up a meter to these terminals, and they not only have an audio tone on them, and I played it with the speaker. It's not very loud, but it's for headphones. But it also produces from 0 to about 0.5 volts AC, so enough to drive a small lamp. And probably it's AC, not DC. So I'll experiment with that a little bit, maybe put a diode LED there, and see if I can get it to actually blink an LED.